Okay, so this is section 4.9 in your book, if I'm not mistaken, Antidifferentiation. And as the name implies, we are basically we're going the other way. Okay, this is in a lot of respects the inverse operation of differentiation. And so whereas, if we say y is equal to x squared and we differentiate, we get y prime is equal to 2x, okay? Now, it winds up being a little bit weirder going the other way, because if I say f of x is equal to 2x, and the way we usually designate the antiderivative is with a capital F, okay? If I have 2x as the derivative, what function is that the derivative of? And you might be saying to yourself, well, of course that's the antiderivative of x squared. But it's the derivative of x squared. Well, it's also the derivative of x squared plus 1, and x squared plus 2, and x squared plus 3, and x squared plus 5,000. Okay? So when I'm anti-differentiating, unless I have what's called a starting condition, like an initial condition, basically this as the derivative does not describe one curve, it describes a family of curves. And since I don't know which one yet that I'm talking about, I have to put x squared and then I have to tack on plus c. Okay? So plus c winds up being x squared plus whatever constant is appropriate for the scenario that I'm actually dealing with right now, okay? And so when we're talking about antidifferentiation, it really just winds up being you have to be careful about the plus c when you need it, and you have to remember how to run in the other direction, okay? So let's go ahead. And we'll do a couple problems from your book. I'll try and concentrate on sorry about the sun just happens to be shining in at exactly that right angle right there. Let me go ahead and, if that's distracting for you. Okay, that's probably a little bit better. Okay, let's do f of x is equal to 1/2 x squared minus 2x plus 6. What is big F of x? Well, we have to go backwards, just like usual. And what happens here is instead of subtracting 1 from the exponent and multiplying by the previous exponent, what I have to do in terms of the reverse rule is x to the n, when you anti-differentiate, becomes x to the n plus 1 over n plus 1. Right? Because if you were to differentiate this, it would go back to this. So the 1/2 comes along for the ride, and that becomes x cubed over 3. And then the 2 comes along for the ride, and it becomes x squared over 2. And then the 6 comes along for the ride, and we get an x. Okay? So that winds up being 1/6 x cubed minus x squared plus 6x plus c. Okay? The plus c is very, very important. Okay? You cannot forget that. Okay, well, let's do a couple more. All right? The ones that are power rule are going to wind up being relatively easy. They're all going to sort of obey that particular rule right there. Let's go ahead and how about f of x is equal to e squared? Okay, trick question, because e squared is a number. That's just a constant, so it's just e squared x, right? Plus c. Okay? Well, how about we go ahead and how about f of theta is equal to secant theta tangent theta minus 2e to the theta. Okay, well, that got really complicated very quickly. F of theta is, well, it's not what is the derivative of, it's what is secant theta tangent theta The derivative of, right? So what do I need to differentiate to get to here? Well, that's the derivative of secant, okay? And therefore, in order to go backwards, secant replaces that, because the derivative of secant is secant tangent. Now, what's the derivative of e to the theta? Well, e to the theta. So the antiderivative, well, that's true, e to the theta as well, plus c. You're trying to go back to a family of curves that give you a derivative in the form of your given function, okay? Now, let's go ahead and, oh, that's a neat one right there. How about number 22 in your book is f of x is equal to 2 plus x squared over 1 plus x squared. What is the antiderivative of that? Well, here you're gonna have to split it up, okay? And you know that that is 1 plus 1 plus x squared over 1 plus x squared. And therefore, that's actually 1 over 1 plus x squared plus 1. Is it not? And all I've done at this point, I haven't done any anti-differentiation. I haven't done anything except for change the form. I've changed the form such that it is 1 over 1 plus x squared plus 1. Now, if I want now to anti-differentiate it, which I can, what is that the derivative of? Well, that looks like the derivative of arctan. Okay, that's the derivative of x, and then I just have to tack on a plus c, and I'm golden. Okay. Now, sometimes, however, when I'm actually asked for an antiderivative, I'm not just given, you know, the function. I'm actually given some qualifying conditions as well. So let's say, let's look at 32. 32 looks pretty good. Let's say, and in these they actually do give it to you as the derivative. So that's 5x to the 4th minus 3x squared plus 4. And let's say that f of negative 1 is equal to 2. Now, without that, that's just what we did before, right? If you're asked for the antiderivative, if you're asked to get back to f, you would put a plus c. But this tells you that we're not dealing with a family of curves that this describes. We're dealing with a particular curve, okay? And therefore what I'm going to do is I'm going to go back to f, okay? Since it has a prime, I don't go from f to big F. If it has a prime, I go from f prime to f. And this is x to the 5th minus x to the 3rd minus 4x. And I need to go ahead and I need to figure out what that plus c is. I'm going to go ahead and plug in the plus c, but now I have an ordered pair that is going to allow me to solve for it. So the output is 2 when the input is 1. Well, that's going to be negative 1. That's going to be minus a negative 1. So those two terms cancel out. This is going to be positive 4. So c is obviously negative 2. And with the initial condition, I can surmise that the original function is that. Okay? Now, what's great about anti-differentiation is the fact that, remember when we talked about gravity problems, and got back to the formula for gravity problems, and it was that inverted parabola. Well, I happen to know that the acceleration due to gravity is 32 feet per second per second. It's a constant. But if I want to anti-differentiate, I need to go back to negative 32t plus an initial velocity, right? A constant. But that constant is a specific constant. That is actually v naught. And then if I want to anti-differentiate again to give me my position function, I know that t is going to become t squared over 2. So that's why it winds up being half of gravity. It's because of the integration here, or the anti-differentiation here, plus v naught t plus initial position, and that ought to look very, very familiar. That is exactly how we get that, why it is the case, okay? All right, let's go ahead and let's do a few more of these. Yeah, I mean, the only hard part about this is occasionally splitting it apart. Beyond that, all you really need is the ability to know how to go backwards, be able to see it, okay? Let's go ahead and let's look at 40. 40 is a neat one. 40 is f double prime of x, and it's 8x cubed plus 5, and I know that f of 1 is 0, and f prime of 1 is 8. And I need to get back to f, okay? Well, let's go ahead and let's anti-differentiate once. Now I know that that's going to make 2x to the 4th plus 5x plus c. Now I'm going to use this to plug in and solve for that c value, okay? And we'll call that c1 since we're obviously going to be doing it again. We have 8 is equal to 2 times 1 to the 4th plus 5 times 1 plus c1. This right here is 7, so obviously c sub 1 is 1, okay? And therefore I have used the initial condition of f prime to solve and get that. Now I need to go ahead and do it for another step. F of x is going to be 2/5 x to the 5th plus 5/2 x squared plus x plus c2. Well, if I go ahead and I plug in 1 for x, I get a 0 output. 5/2, I get a 0 output for f, plus 1 plus c2. Well, this is going to be a little bit more messy because this is 2/5, this is 5/2. I need to get a common denominator. Let's use tenths, okay? This is 4/10. This is 25/10, okay? So 4/10 plus 25/10 plus 10/10, c2, 0. Now this winds up being 39/10, or c2 is equal to negative 39/10. And I know that my f of x is 2/5 x to the 5th plus 5/2 x squared plus x minus 39/10. Unless I made an arithmetic mistake there somewhere, which I don't think I did, but you get the idea, right? When I'm given it, I still put the c value, but I use those conditions, those ordered pairs that I'm given for whatever function it is that I'm given. I use those ordered pairs to solve for the constants more than once if I have to, as is the case in this particular one, okay? Now, that is basically anti-differentiation, and I doubt that there's going to be anything more than just the mechanics on this. If there is, please do shoot me an email, and I will try to supplement this single video on it, but I don't think we really need anything more than this single video. Good luck on the test, guys. Like I said, I will talk to those of you, email me if you need me. I'll talk to those of you on Saturday who are going to be involved in the Skype session. Bye.